Welcome back. Hopefully those trapezoids went well for you. The one of them you had to use special right triangles, as I alluded to. Hopefully I didn't give away too much of the fun. Let's talk a little bit about trapezoids and kites and rhombuses and how they kind of fit in with other quadrilaterals. So up at the top here we have a quadrilateral. It is any four-sided shape. Quad means four, lateral means sides, four sides, it's quadrilateral. And then we have all kinds of different classifications of quadrilateral, and there is a little bit of disagreement around trapezoids. So some people would say that a trapezoid has at least one pair of parallel sides. And if you think about it that way, that means that this is a trapezoid because these sides are parallel. This is a trapezoid. This is an isosceles trapezoid because these are parallel and these two sides are congruent, just like isosceles triangle. Now this has at least one pair of parallel sides. So some people would say that a rectangle is a special trapezoid, as well as a parallelogram and a square and a rhombus. So some people would say that all of these things are trapezoids. Just like you know how a square is a rectangle, right? This diagram is saying that a square is a rectangle is a parallelogram, a square is a parallelogram, a parallelogram is a trapezoid. They're all quadrilaterals. And that is one definition of trapezoid. The definition that our textbook uses is slightly different. It says they don't like all of those things being called trapezoids. So they say exactly one pair of parallel sides, which means as soon as you have more than one pair of parallel sides, that it's not a trapezoid anymore. So in other words, our textbook would say that these are trapezoids and that these arrows should not exist. Does it matter? Well, the formula that we use for the area of a trapezoid, which says that it is 1/2 height. I keep doing that. Get ahead of myself. 1/2 height times base 1 plus base 2. That works for trapezoids, and it will also work for all of these other shapes that some people would call trapezoids. Oops, I wrote the equation off the screen. Sorry about that. Whoa, now it's crazy. There, now you can see it. That kind of works. All right. So that equation does work for these other shapes. So I think there's an argument to say it is, but our textbook says it's just these ones are trapezoids. Okay. Now, that's just kind of a side note about trapezoids, not super critical. Interesting that these definitions aren't necessarily universal, even in this day of the internet. Now we're going to move on to kites. So, I want to get rid of some of this stuff. Let's see what happens if I do this. All right, let me get rid of some of this stuff so I can talk a little bit more. There we go. Okay, now we're going to talk about kites. And And it won't let me draw. Oh, there we go. We're going to talk about kites. And kites are... Then we're going to talk about rhombuses. And as you can see from this diagram, a rhombus is a kite. It's just a special kind of a kite. Kites have two pairs of congruent sides, and rhombuses, all these sides are congruent. So let's look a little bit more closely at kites. So here is a website I really like. It's called Math is Fun. It's very neat. They've got a nice reflection of that city up top. And you can find stuff like the definition of a kite here, and they usually do a pretty good job of having some good information, not too much information. I'll put this link into the presentation for you. So it says a kite is a flat shape with straight sides. It has two pairs of equal length adjacent next to each other's sides. So the red sides are the same length, the blue sides are the same length. And then they note that we call it a kite because it often looks like a kite. Another thing that is important about kites is that the diagonals, if you connect the corners, are perpendicular. So the diagonals are perpendicular. And these two angles, A and A, will be congruent. And this shorter, well, I guess it's not always shorter, but the diagonal here that is between the red and blue sides will get exactly cut in half by this other diagonal. And those diagonal properties are kind of why you see kites that look like this, because they have those sticks holding them together, and you want those sticks to be perpendicular, and you want the stick going across to be cut exactly in half by that longer stick. Here you can see between A and C, segment BD will always be in the middle, and it doesn't matter how I arrange this, it makes itself a kite. So this has some rules set up. You'll see if I show the angles that angle A, B, and D change, and they're different. But A and C, no matter what I do to this kite, A and C always stay the same. That's one of the properties of kites. And you can see if we look at the side lengths, that these two longer sides are the same length. And then the two others, you have two pairs of congruent sides, no matter how this gets moved around. So there's some of the important things to know about kites, but what we want to know is how do you find the area of a kite? So, in order to understand how we find the area of a kite, let's look at this kite. Now, I'm not going to draw this one out in paper, but you use your imagination here. If we took this and we moved it, we'd have to flip it upside down, and we moved it here. We know that these two are the same length, so they're going to match up perfectly, and our other two angles are going to be right angles. So actually right there, I am going to have a rectangle. And I can do the same thing with this red triangle. I can move it over here and put it right there. And now I have made this rectangle. And the height of that rectangle is, let's call this diagonal 1. The height of the rectangle is going to be diagonal 1. And if we call this other side diagonal 2, well, the width of this rectangle, remember how we said that that diagonal got cut exactly in half? the width of this other rectangle is going to be 1/2 of diagonal 2. And then we just multiply those together, you get the area. In other words, the area of a kite is 1/2 times diagonal 1 times diagonal 2. So if you know the diagonals, you can find the area of a kite. When you are answering questions on kites, they might tell you the length of this entire diagonal, or they might tell you that in 2 parts, in which case you'd want to add them together. They also might just tell you half of this diagonal, since you should know that the other half will be exactly the same. So go ahead, try the kite problems, and then we'll look at rhombuses, which are pretty, well, let's just do rhombuses right now, because rhombuses are really similar to kites. So here's a rhombus, and the thing about a rhombus is that all 4 sides are congruent. So all 4 sides are the same length. And that means that the diagonals must be perpendicular, and they're both going to divide each other in half. So this one gets divided in half, so that's congruent on both sides, and this one gets divided in half, so that's congruent on both sides. And the formula for the area of a rhombus is the same as for the area of a kite. It is 1/2 diagonal 1 times diagonal 2. So these rhombuses, you might have to use special right triangles. You might have to use the Pythagorean theorem. There's a lot of different ways to give you, partial information here, and let you be able to use what you know about geometry to fill in the blanks. So be careful when you're working through those. Think carefully. The important thing to remember is all of these congruencies exist. And if you know that, you should be able to figure out the area of each rhombus as well. So on the next couple slides, we'll have rhombuses and kites for you to find the area of. And then we'll look at a few questions that involve some of our previous knowledge a little bit more. And that, but yeah, those 2 formulas, the area of a trapezoid and the area of a kite or rhombus, and then the properties of kites, trapezoids, and rhombuses. Those are the things that you'll need to know in order to be able to answer these questions. So make sure you have those in your notes. And good luck on these next problems. There will be a mastery check today that includes Monday's lesson and today's lesson. There will be assessment on Friday that has all the lessons for the week. I know there were some problems with Nearpod on last Friday, but there's no penalty for late work. So use your time appropriately, and if there's anything that you haven't got done yet, make sure you get it in. All right, good work. I will see you in our next lesson.